This is our CCR project by Iveta,
Mari,
and Sophia. And today we're going to be talking about the 3 types of heat transfer. The first type is conduction, which is the transfer of heat through direct contact between materials. Heat moves from hotter objects to the cooler one by particles bumping into each other.
Next we have convection. Convection is the transfer of heat through liquids and gases. And a key word for convection is hot air rises, cold air sinks.
And the last one is radiation. Radiation is a transfer of heat through electromagnetic waves without needing any direct contact or a medium.
Iveta, what are you making? An egg. How does that work? Let me show you. This is an example of conduction because the stove transfers heat into the metal pan, and then as we crack the egg and put it into the pan, the heat from the pan will transfer into the egg. Heat transfers from hot to cold, which is why the heat from the pan is transferring to the egg and cooking it. Notice how the egg is frying even after the stove is off? This is because metal is one of the best conductors to transfer heat with. Metal also has a low heat capacity, which means it'll cool down in less time.
Thank you, Iveta.
Hey Mari,
Yeah,
can you show me an example of convection?
of course. I'm gonna make our main coffee just for you, Iveta. Okay, at first I'm gonna heat it on the stove. So, let me explain this to you. The bottom of the water gets hot first, so it becomes less dense and the hot air rises. Therefore, the cooler liquid on top sinks. Remember those key words. This creates a cycle that keeps repeating. Look at the steam. This is the hot air rising.
Thank you, Mari. Of course. Now I won't forget that hot air rises and cooler sinks.
I got you.
I'm so craving s'mores right now.
I know, right?
Wait, isn't there physics behind s'mores?
I can show you.
Oh, thank you.
This is an example of radiation. Radiation is heat transferred through electromagnetic waves and it doesn't need direct contact. Look at the marshmallow. It's not touching the fire, but it's still heating up. That's because heat is traveling through the air in infrared waves. The heat energy radiates from the fire to the marshmallow, roasting it with no pan or boiling water, just pure infrared waves.
Thank you, Sophia.
You're welcome.
Okay. We see heat transfer everywhere in life, and it is important to be able to tell the difference between them all.
Each transfer has its own special aspects.
This concludes our CCR project.
Thank you, Ms. Batra.
Because heat is traveling through the air in infrared waves. Heat is traveled through the air in infrared waves from the fire to the marshmallow, roasting it, and it will no pan or boil.
CCR project.
Thank you, Ms. Batra.